Good morning. My name's Rainier Mann. I manage a group called the Water Quality and Investigations in the Department of Environment and Science. My group has two large monitoring programs. We monitor nutrients, sediment, suspended sediments and pesticides in the catchments of the Great Barrier Reef and southeast Queensland. Pumicestone, we're in southeast Queensland, and I'm going to talk predominantly about one of the sites which is in our southeast Queensland network, and that's Coochin Creek. That is actually pictured on the front slide. But I'm also going to talk about another couple of sites which are further south. Okay, let's keep going. All right, so we monitor in two ways. We either go down and we collect water in a bottle and send it to a lab, or we use what's called an auto sampler, which collects water samples automatically, and we trigger it remotely. Here at Coochin Creek, we have, and I know the people online can't see my pointer probably, but we have like an intake in the river that's just beside the weir there, and it pulls it up to a shed. This is actually a DNRME gauging station where they gauge water flow, and we share their infrastructure. And inside that shed, we have what's shown here as two auto samplers. One of them is for nutrients and suspended sediments, and the other one is for pesticides. The one for nutrients has been there for about 10 years, not the same one. We replace them up periodically. And the other one for pesticides has actually turned up, it was put in at the beginning of 2019. And as I said, collecting water in bottles by hand is also an important part of our process. I want to stress that all of our data collection and data manipulation is done with a quality management framework. We are the Queensland government. It is very important that we put out reliable data that we have confidence in. So we have a stringent quality assurance and quality control program. I'm going to talk about three sites. Coochin Creek is the site where, in the Pumicestone, where we've been sampling for the longest. We've been sampling for over 10 years. In Coochin Creek, this is a wider catchment. But the section that we actually monitor is that. The purple is horticulture. We don't break it down any further than that, so I can't tell you. I don't actually know whether that's pineapples or strawberries or macadamias or avocados. We used to sample a much smaller catchment called a sub-catchment called Back Creek, but we stopped that about a year ago simply because the wider Coochin Creek catchment pretty well told us the same story without sort of pinpointing individual growers, because that was a very small catchment. The other catchment I'm going to talk about is 6 Mile Creek, which is much further south. I think I'll just mention that horticulture represents a very large portion of Coochin Creek, and in 6 Mile Creek, horticulture represents about somewhere between 20 and 25% of the land use. And this is the portion that we actually monitor in 6 Mile Creek. And the last one is actually Lagoon Creek, just near Caboolture. That's actually not in the Pumicestone. That empties out into the Caboolture estuary, but it's an interesting site to compare with. Again, about 20% horticulture and a very large urban footprint as well. Okay, we're going to get into quite a few graphs. Hopefully not too complicated. And I'm going to talk about only about four or five different analytes, different parameters. The first one is nitrate. We analyze about 9 different species of nutrients, phosphorus or nitrogen, but the only one that I'm going to talk about today, because it's notable, is nitrate. So we have a graph, we've got dates, we've got a blue trace which represents the height of the waterway. And that when you see a peak, that represents a runoff event where there's been rainfall. And that's very useful because most of the time when we see contaminants in a waterway, they get washed in after rainfall. The other thing here we have, of course, is all the orange dots, and they represent the concentrations of nitrogen as nitrate in that waterway. We've got a time span of about 6 years here, from 2014 to just prior to the present. I haven't actually got the most recent data from this current wet season, not for this particular site anyway. It's interesting here because we actually, when we do get a rainfall event, the actual concentrations of nitrate tend to drop because it's getting diluted out by a lot of water. So in between rainfall events, we can get some quite high numbers, and that's because we think it's actually coming in from the groundwater. So it's slowly coming in the whole year round, and when there's not a lot of flow, the concentrations get quite high. So I'm going to, okay, and most importantly, because it's really difficult to understand what those numbers mean, so we have to have kind of reference, and what we have here is a yellow line down the bottom of that graph, which represents the water quality objective for this particular waterway, which is 60 micrograms per litre. So all these data are in excess of an order of magnitude or more than 10 times the water quality objective. And the water quality objective is what is typical for a waterway in good condition. These numbers up here are in the ballpark of the new toxicity value for nitrate. I haven't put that line on because it's currently under revision, but I expect that line to go smack through the middle of those data. That's the median of all those data, and I think the nitrate toxicity is going to be around 2 or 3. That's exactly the same graph. I've just added some purple dots at the top end, up the right-hand side, and that's the data for 6 Mile Creek. We've only been sampling for the last 9 months or so. They're all manual grab samples. We don't use an auto-sampler, and that's kind of important because with an auto-sampler, you tend to collect stuff at the first flush as the water comes through because we trigger them as it rains. So these represent opportunistic sampling, and as you can see, we're getting the same kind of spread of data as we saw in 6 Mile Creek. So 6 Mile Creek isn't unique. We've seen that in another waterway there as well. And the last thing I'm going to add is the data for Lagoon Creek. Again, it's a creek with a lot of horticulture at the top, but also a large urban footprint. And the numbers are much, much lower, and some of them even fall below the water quality objective. Okay, so that's nitrate. I'm now going to talk about pesticides, and the important thing about the graphs I'm about to show is there's also another line which is called the guideline, or the Water Ecosystem Protection Guideline. And that's got their guidelines which are derived using toxicity testing with animals from the ecosystem, be it plants or crustaceans or insects or whatever kind of data we can get our hands on. And if it's something higher then there may be a risk. If it's low, if the numbers are below the guideline, then we consider there to be a low to very low risk. There's 3 rules of thumbs with pesticide concentrations. Is if you get concentrations which are much higher than the guideline, then we think there might be a risk, and there should be investigation. If you get chronic exceedances of a guideline, even if they're relatively not particularly high above the guideline, but if they're there all the time, then we think that ecosystem's at risk. Or if we get pulses through the season or through the years, then we think there's a risk. Okay, so this is a herbicide called Diaron. We've been looking at this, we've been seeing this herbicide in Coochin Creek now since about 2014. I would point out that this red arrow here on the graph is at the point in time when we put in the auto sampler. Everything before was collected by hand. Now, the important thing about that, like I said before, is you tend to catch those first flushes, and that carries pesticide into the water. So it's actually no surprise that we get higher numbers when we use an auto sampler. This should not be an indication that it's getting worse. It's just that the sampling regime is slightly different, and we tend to see those higher numbers. This is the water quality. This is the water quality guideline here for the protection of ecosystems. That number is going to change this year. That's been the number since about 2000. It's always been an interim number. There is a new number submitted to the National Water Reform Committee, and it's going to go up, but not too far. This is the green line is the irrigation guideline, so it indicates the quality of water for irrigation purposes. I'll add 6 Mile Creek there as well, and Lagoon Creek. 6 Mile Creek looks pretty much the same as Coochin Creek, and Lagoon Creek, although we do get some big numbers, are generally much lower. Oops, sorry, going the wrong way. Okay, another pesticide, and it's also a PS2 or photosystem 2 inhibiting herbicide like diaron is bromacil. We also see very large numbers that exceed that guideline value. We see it, we've seen it for a number of years now. Again, the numbers have probably gone up a bit since we put the auto sampler in. I've got the 6 Mile Creek data there as well, and the Lagoon Creek data. So it's telling much the same story as we see at Coochin Creek with respect to 6 Mile Creek, and the numbers are definitely lower here. This yellow guideline is a draft guideline. It hasn't yet been submitted for national endorsement. It will probably be revised slightly, so I wouldn't take that to heart. That number will probably go up a little bit or down a little bit, but that's more or less the ballpark it's going to sit at. Amitrin, another PS2 inhibiting herbicide. We do not see quite as exceedances of a guideline quite as frequently, but it is fairly consistent. That guideline is also a draft guideline, and this guideline has been submitted to the National Committee as well. Same story. Coochin Creek, 6 Mile Creek looks similar. Lagoon Creek, the numbers are much lower. The last chemical I'm going to show you is chlorpyrifos. This is not a herbicide. This is an insecticide. It's a very old insecticide. In many jurisdictions around the world, it's actually no longer in use. It's called an organophosphate insecticide. It's that class of insecticides that took the place of organochlorines like DDT and dieldrin. It's a very toxic chemical. The guideline, which has now been existing for a long time as a national guideline, is 0.01 micrograms per litre, and that's our detection limit most of the time. So we see a sort of a straight line of numbers there or down below it, and they're our limits of detection. So the numbers above that line are real detections, whereas these, we can't actually say how much was in there. But we get a lot of numbers here. We got the red arrow, which indicates the time when we put the auto sampler in. The green arrow on the left indicates the time that we actually changed the analytical procedure that we used prior to 2016. The analytical technique we used didn't even see chlorpyrifos. And then we changed the technique we used for analyzing it. Suddenly we could see it. So the absence of the data on the left here doesn't mean it wasn't there. It just means our analytical technique couldn't see it. We get numbers well above the guideline value. We do only tend to see it when there is runoff events and not so much beforehand. Things like the PS2 herbicides, diaron, bromacil, amitrin, we did tend to see them between runoff events, which suggested that some of it was coming through the soil profile as well, or through the groundwater. This one tends not to be as water soluble, and we tend to see it only as runoff. Okay, they're the only ones I'm going to show you graphs of, because they're the ones that exceed either draft or national guidelines. We see a lot of other stuff in there as well, in all those creeks. Not so much in Lagoon Creek. We don't actually. In fact, we only saw trace amounts of chlorpyrifos in Lagoon Creek. We see other numbers, and I'm not going to show you all those graphs. We don't have time. So what I'm going to do is actually spruik a new online platform that we have. It's called the Pesticide Reporting Portal. It will be a place where the public and anybody can see all of our data throughout the GBR catchments throughout southeast Queensland. It's not available yet. I expect it to be publicly available within about 2 weeks. And it's a way of, it has a mapping interface. You can actually go to your site of interest, in this case, let's say Coochin Creek, and then there are 24 different pesticides which you can view the historical data. And you can also show land use on the same maps. And then you can actually narrow into pesticides of interest. This one is diaron again. Some of the colors are a little different here, obviously. But you can see that all the way back to 2011, I think. There's also fairly detailed information about the guidelines, where they actually come from. There are links to the documents where that guideline come from. There is information about the status, whether it's going to be revised in the near future or not. There's only 24 there, and the reason there's only 24 there is because, analysing these things are expensive, and we don't necessarily have information for everything that's there. For example, there's not a single fungicide in the pesticide reporting portal because we don't analyse them. It's an area that we're trying to get more into because we think that fungicides are an issue in a lot of catchments. Some pesticides we don't even show because we don't think there's a risk. For example, we did spend a few years looking at glyphosate, or 1 year looking at glyphosate, and we always found that the concentrations were much lower than guidelines. So we don't bother because it was an extra analysis and relatively expensive. There's a lot of chemicals that there are no guidelines available for anyway, and so there's no reference for us to compare to. And some are extremely difficult to actually analyse. For example, mancozeb, which is a fungicide, you can't actually measure it in the environment. You can only measure breakdown products, and it's very difficult to actually interpret that data. That's the team. Fairly large team because we cover the entire east coast of Queensland. And I did have my email address up there, but it's obviously disappeared. So, thank you.